Hey, John here. Let's have a look-see at one of the pages on the course website here, all right? So if you go down to the bottom, near the bottom down here, what do we got? This link right here, constructor initialization lists, okay? If you open this up, let's look at this notation on how to initialize variables in your objects, all right? So this is going to give us some examples of what is obviously a constructor of a class called date, right? So the constructor has these three arguments, and presumably maybe you have these three integer variables inside this class, and you can assign them values based on the arguments given to the constructor. We've seen that before. I'm sure we've all written code that works that way. Here's another way to do the same thing. It's the same exact constructor, and then you put a colon here, and then you name the variables like this. I say the month variable, instead of assigning it the value of m in here, I can say make month be initialized to m, all right? Make day be initialized to d, and make year be initialized to y, and this will get done before the body of the constructor runs. Now, in this particular example, this really doesn't make any difference. However, in other cases, it makes a huge difference. In fact, the initializer list may be the only way to deal with certain situations. All right, so that's why we need to understand them. Let's look at this thing here. There's here's an employee class, right, and a constructor. And maybe you have a bunch of arguments like shown here. You got a string and some integers in here. Here's your colon. So this down here is your initializer list of two things. This one here, comma, this one here. Two member variables that are in the employee class, all right? So obviously this thing here must be a string, most likely is a string, right? Whose name is employee name. And when you say this, you say, look, when you construct the string object that is a member variable of my employee class, use the constructor that takes a reference to a string and give it the name argument rather than, and here's the difference, rather than constructing an empty string object and then later on change the value of that string by saying something like employee name equals name down here in the code. All right, big difference. What if you have a date member object inside of your employee class, right? Well, this changes completely which constructor will be called, as does this one down here on the string, right? This one tells the class that when the member field called hire date is constructed during the construction of the whole object, don't call the default constructor, call the one that takes these three arguments, all right? That's a big difference because some objects have a huge amount of complexity involved in constructing them. And the last thing you want to do is construct something only to replace its guts immediately after. That's when these come in pretty darn handy, okay? So what do we got going on here? We talked about this in lecture in the past. What happens if you have a month is the name of your, like down here. What if you have a month variable is an argument in a member function, and you want to refer to a data member of the class that has the same name? Well, you can just say this right arrow month equals month here. If you don't specify, it'll use the closest, the thing whose scope is the closest, right? So that would be this argument here is what you're referring to with this month there. And if you just said month equals month, that would do nothing. So you have to tell it the other month. And this right arrow month refers to the month member variable that presumably exists in this particular date object. If you use an initializer list like this, the month over here refers to the month member of the class, and the month in here refers to the argument in this list. All right, so that just resolves the discrepancy based on, which one takes the right priority, and this just makes sense, okay? The other way to do it is don't name them the same thing, then you don't have to worry about that confusion. Now down here we give you a list of when you want to use these versus not use these. What happens? A data member that is const but not static has to be initialized somehow. All right? This is one way to do that, okay? Data members that are references. Well, if you have a reference data member, remember a reference has to be set once and only once, and then you cannot change the thing it refers to, right? So if you have a reference member variable, it must be initialized using an initialization list, because you can't say the reference called something or other in the middle of a function like this and change what it refers to. So this notation up here would be the only way you can use to deal with that. What else we got? It can be used to explicitly call a constructor that takes arguments. This is the case that I was just talking about that's exemplified right in here. Use this constructor when you create and initialize the date object that's inside of my employee, please. Don't use the default and then require me to change the values down there. That's what's being referred to here. We'll talk about this case in the next lecture. In a derived class, when you have inheritance going on, you can use the initialization list to figure out which base class constructor that you want to use, all right? And like I said, we'll talk about that after we talk about inheritance in the next lecture. So let's, armed with this information, let's look at some code. I don't like talking about stuff. I'm a doer. I want to see what's going on. So what I did is I took the information out of this page and all the things that it implies, okay? If this is the constructor that we want to call, how does this object work? What's implied by this, right? Well, obviously, if you're going to do something that looks like this, most likely you got a month, day, and a year member variable inside here. And in this constructor, as it showed in the web page, we can initialize them like this. I threw in a thingy here that prints out, hey, I'm the date constructor, and I've been entered, and I print out all the values. So we can actually see where the program runs. Hey, somebody constructed a date, and here's what they gave it, all right? Here's the employee that I suggest is implied by the web page, right? So here's an employee. Maybe you've got an employee name and a hire date field in here that is suggested by this right down here, right? Okay. And the rest of this is given on the page, right? So if you have a constructor that takes these items, how can I create a date up here using this date object up here? Because I have this constructor, I don't have a constructor that is no arguments. I only have a constructor up here that takes these three. In other words, I cannot create an instance of this date class unless I give it these three arguments. Therefore, if I did not put it in the initialization list here, this object, if I created an employee, it would have to have a way to create a date object with no arguments. This won't even compile if I don't use this technique, all right? In fact, that's what this little comment right there says. So here's my main. I just say, hey, let's try to create an employee. John must have been hired in January 2nd of 2020, right? So we can see this thing go and print out all this stuff. So let's go ahead and make this and run it. Okay, so what happened in there? It printed out that the date routine was entered, and it prints out the employee date routine. The date constructor was entered, and it prints out that the employee constructor was entered. So let's look again at what's going on there. Remember, here's the constructor for the date, and the first thing it does is print this out, right? Here's the constructor for the employee. The first thing it does is it prints this out. Now, notice what happens in here. Notice it printed out that the date was constructed prior to the time it prints out that the employee was constructed. And that makes sense if you think about it. It's going to do all these initialization routines up here before it runs the body of the constructor here, all right? So let's see what happens. Like I said, let's see what happens if we comment out this thing, right? If I put that in there, I got to remove this comma, right? So I'm going to move the comma down here so I can remember to put it back in later. What happens if I do this? There's no default constructor, right? It's not even going to compile. You get all kinds of weird stuff going on. It says, hey, look, in this constructor, there's no matching function for call to date with no arguments in here. All right, so this is what the compiler will say when I'm trying to construct my employee object on line 34. Okay, and then it says, oh, by the way, there is one that looks like this. And then it goes on to explain, that particular candidate expects 3 arguments, but I didn't give it any. So this is helping me figure out how to fix my problem. And it goes on and on and on and talks about it. Hey, here's where the class is, and hey, you need to resolve this. So this gives us a lot of help in a reasonable context for us to understand how to do this, right? Now, again, you can't do something like this. You cannot, I meant to say, do something like this. All right, so 1-2-2020. If you do this, by the way, we'll see an example of this weirdness later on. But if I put this in here, what this means, all right, let's not put it there. Let's put it down here. Why? Because I can't do it up there, right? Let's comment all this out. Let's comment out the entire broken employee class and look closely. Make sure that we understand, what does this mean? Will this compile? I say, yes, it will. What does it mean, though? This is just a constructor of a data object. Let's have it reveal a few things about itself, all right? Let's put a destructor in here. And in the destructor, we'll also print some stuff out. We'll do that. All right, well, of course, we can't do these variables. We have to use the right names, right? The message that I made a copy of in the constructor is actually printing out the arguments that were passed into the constructor. They're not printing out the member variables, right? Simply because I printed out before I assigned them. But now I have a little thing that'll print out that the constructor was called and the destructor was called. So if we compile and run this, and I say I believe it will work, yes, what happens? It constructed a date with these numbers, and then it destructed it. And that makes perfect sense. This is constructing an object whose scope is the duration of this one single statement, and when you get to the semicolon here, it destructs the object. This is why you cannot put something like that up in here. You could put one in here. In fact, just for fun, let's go ahead and do that. And let's see what happens. It'll do the exact same thing it did down there. Now, to make sense, let's put 22, 22, 22 for these variables. I say nonsense, actually, but it's recognizable. If I invoke and construct a data object, we can recognize this data object is unique and distinct, different from a date that might get called with these numbers down here. So let's go ahead and fix this back the way it's supposed to be. All right. And we're going to construct an instance of the employee object right here, right? Class employee. And we're going to pass it John and these 3 values. It'll create the string. It'll construct, I should say, the employee name string with the thing that I pass in with this variable there. It'll call the constructor of the date object on behalf of this member variable and construct it with these 3 arguments here. And I'll go ahead and leave this one in down there as well. And what you'll see here is that it will construct the... No, there's too much noise here. Let's run this again. All right, here we go. I run the program. First thing it does is it says, hey, somebody constructed a date whose values is 1-2-2020. So this is the date that's constructed on behalf of the constructor for the employee object. After that, it executes the body of the employee object constructor, and the first thing it does is it prints out that it's been constructed. Then after that, it continues through the body of the constructor of the employee object, and it creates and then destroys the date object like it did in the main. And when it's done down here, the employee object itself is destructed, which cascades into the member variables. Okay, so let's look at this in there next to the source code here. All right, so what happened? I construct it. Only thing the main does is it creates an instance of employee called E right there. So what we saw was, the first thing we saw was the date get printed up with the 1/2/2020. That's because this thing was called during the construction of the employee object before this code here, the body of the constructor, got called. So once the body of the constructor for the employee object starts running, the first thing it does is it prints this out. So I run the program. The date says, hey, I was constructed, and that happens prior to the body of the employee object starting to run, which prints out this. And then the next thing that happens is the body continues, prints out our wonky, foolish date, and then it goes out of scope right here, and you see this date destroyed. Then the constructor returns back into main. Main eventually returns. The employee object goes out of scope right here, and the employee object itself is destructed. And because it has a date in there and a string, both of these will have their destructors called. All right. If I wanted to, I could put a destructor on the employee, just like we did above, on the date object, and say, hey, I was destructed. Let's go ahead and do this. And this time I used the which actually I can't do that. I don't have, those are not my member variables. All right. So I'm going to just print the name out in this case. I got to put this back in there, right? So this one's just going to say employee such and so was destructed. Okay, so the destructor function here, the member function has been entered. So let's go ahead and compile that one. And I can't type because I used the wrong variable name. Name here is wrong because it is the argument to the employee constructor. I wanted to print out employee name, which is the name of the member variable. Okay, so now we got all kinds of fun stuff going on here. I say, run the program. He creates, he constructs and initializes the date member variable before the constructor for the employee runs. The pointless date is constructed and destroyed. Then we go back to main. The employee object goes out of scope. And you'll notice this is running in backwards order. Let's get rid of the pointless date thing in here that's noising up the place. All right. Let's get the nice stuff on the screen. Look what happens. First we have date. Then we have the employee constructor finishing. When it goes out of scope, it runs in the opposite order. The employee object is all cleared out and destructed. Then its member variables are destructed. And this makes perfect sense, right? Why? Well, because in this destructor here, I should be able to use and access, if I want, this date object and this string object. If it destroyed this string before it ran this destructor, I couldn't print out the name in the destructor. So you have this notion of you do A, B, and C when you're constructing. When you then destruct, it does C, B, and A the other way around. All right? So conclusion, big picture, what's the takeaway of all this? These initializer lists that come after the colon in a constructor are really useful to pass arguments into these constructors that need to be called on behalf of these member variables. And we'll see some other uses for this that are really useful and important in the next lecture. So thanks for watching. See you next time.